In this video, I'm going to be working some integrals, doing some techniques of integration. You see on the front side, this is a UDU versus UDV sheet. Looks like this one didn't really fit the pattern. I'm not sure how that one snuck in there. So what I'm going to do, I'm going to start off by going in and labeling which one is going to require UDU versus which one is going to require UDV. So I'm going to use a pink pen for UDV and a blue pen for UDU, right? And because I know, especially this year, one of the big things that students in my class have had trouble with is recognizing the UDU pattern. So first I'm going to go through and I'm going to try to find all of the ones that are UDU. Because the UDU pattern is an integral of a composite function, so something like, f of g of x, and then you see with multiplication on the outside of the composite, multiplication by the derivative of the inside of the composite. Okay, and then generally in this class, we're going to let u equal g of x. Okay, and then du is g prime of x dx, and go from there. All right, another one that, it does fit this pattern, but I just want to throw it out there, is u prime over u, right? This is going to be a pattern that we'll see. In fact, I think I've got one, let's see, u prime over u, where is it? Here it is, right? I guess maybe not. That's not exactly it. That one's gonna be a little tricky. I'm gonna work all of these for you. U prime over u. Nope. Yeah, maybe this one's u prime over f of u, but whatever. I'm not gonna get into that too deep. Okay, so I'm looking for something that is the derivative of the inside of something else, or really something that's the derivative of something else connected with multiplication, right? This one, the derivative of minus 4, is going to be related to x to the negative 2/3, and that's x to the negative 2/3. So I'm going to say that that one is UDU. Okay. I'm seeing a composite here, but I'm not saying, x is not the derivative of 2x, so that one's not going to fit the mold. Over here, cosine is the derivative of sine, and sine is the inside of a composite function. This is going to be UDU. Okay. This one, okay, what do I got going on here? I've got the derivative of x squared plus 6x is 2x plus 6. 2x plus 6 is twice x plus 3. That's going to fit the pattern. Okay. And so when I say multiply by g prime, we're going to be okay with any time where it's maybe proportional to g prime. Maybe not exactly equal to, but proportional to it. X e to the x. I don't see anything that's the derivative of anything else, so that's probably not going to be it. X sine of 2x, very much like x cosine of 2x. No. Okay. Now here, I see e to the x squared and x, okay? And I think what I'm going to do is I'm going to say, well, the derivative of x squared is 2x, which is proportional to that. And that's how I'm seeing it. But what we're going to eventually do is we're going to say that this is e to the negative u multiplied by some kind of du thing, and it'll be all right. X squared log of x, nothing is the derivative of something else. Okay, here, negative x to the third, the derivative of negative x to the third will be negative 3x squared. So it's proportional to that. This is a UDU scenario. All right, moving forward. Okay, no. But this is going to be the derivative of x to the 3/2 is 3/2 x to the 1/2. That's x to the 1/2. Okay, so this is going to fit. This is neither. This is power rule. I'm really not sure how this got on that worksheet. I think I might have had the wrong integral on the clipboard and pasted the wrong thing. Okay, e to the x minus x, e to the x minus 1. Here's a u prime over u. Okay, the derivative of e to the x minus x is going to be e to the x minus 1, and that's up here. Okay, this is definitely UDU. We're going to let u equal e to the x minus x, then du will be this dx, and it'll be 1 over u du. And we know how to antidifferentiate that. That'll be pretty straightforward. Okay, again, x squared plus 9, the derivative of that is 2x plus 0. Okay, that's proportional. I'm happy. Okay, x squared sine x. Okay, that's going to be UDV. Nothing is the derivative of something else. 4 minus x squared times x. There we go. That one's a lot like the one from this year's operational BC free response. Okay, derivative of x squared plus 2x is 2x plus 2, which is, proportional to x plus 1. Did I already? No, but this one is the exact same as, you can't see it anymore, that one, right? I mean, it's off by the numbers, but otherwise it's pretty much the same. Okay, so the derivative of x squared plus 2x is 2x plus 2. That's proportional to x plus 1. I thought I'd already seen that one, but okay. This one right here, what's going on here? All right, this one, okay, we can do this a number of ways. What you can do, you can actually expand this, by multiplying it by itself to square it and then distribute it in the x. Or you can use UDU with u being x squared plus 2 because, this is proportional. I think I might do UDU on that one. X e to the 2x, not something being in the derivative of something else. Very similar to x cosine of 2x, x sine of 2x, those are the ones we saw. And then there's this one. Here I've got x and 1 plus x squared squared. This one's going to be UDU also because of, the derivative of 1 plus x squared being 0 plus 2x, which is proportional to that x. Okay. The rest of them, except for that one, the rest of them will be UDV because I've got a relatively simple product in my integrand. And nothing is the derivative of something else, x squared sine x, right? And most importantly, I'll be able to take the antiderivative of at least one of them very easily. Okay, this one I can take the antiderivative of secant squared x pretty easily. X squared log x, x e to the x sine of 2x, x cosine of 2x. All right, so, whoops, there you go. Really colored in the rest of them, besides this one with pink. So now what I'm going to do is I'm going to kind of just work these one at a time. And so this is going to be a long video. I'm going to do all the UDU ones first, and then I will do all of the UDVs. So that if someone is scrolling through the video, and they need help with just UDU, they can just, watch one section. So for this one, I'll label that one number 1, or blue number 1. So I'm going to let u equal x to the 1/3 minus 4 so that du is 1/3 x to the negative 2/3 dx. Now I've got 1/6 of x to the negative 2/3. So I'm going to say 1/6 x to the negative 2/3 dx. That's like everything that's not u to the 5th. That's going to be equal to, I had to divide all of this by 2, so I'll say 1/2 du. Now I'm going to go over here and I will say, what am I going to say? This is going to become the integral of 1/2 u to the 5 du. Because the 1/2 in du encapsulates all of all of that and the dx. Right, so that's going to be 1/12 of u to the 6th plus c. But an antiderivative of this thing with respect to x should be in terms of x, so I'm going to substitute back in on that. U is equal to x to the 1/3 minus 4. And I'm happy. The second one. All right, I'm going to let u equal sine x so that du is cosine x dx. That's exactly what I have, so I don't need to do any more fiddling here. I can say, well, when x equals 0 means that u is equal to the sine of 0, which is 0. And if u is x is pi over 2, that means that u is going to need to be the sine of pi over 2 is 1. Okay? So this becomes the integral from 0 to 1 of e to the u du. And then antiderivative for e to the u is e to the u. From u equals 0 to u equals 1. And that's going to be e to the 1 minus e to the 0. Let me slide this up a little bit. And, all right. Calling that one number 3. All right, so I'm going to let u be x squared plus 6x. then du is 2x plus 6, yeah, dx. But all I have is x plus 3 dx, so I'm going to try to match that. Okay, I took this and divided it by 2, so I'm going to do the same thing on this side of the equation. And then this is a definite integral, so I'm going to need to change my x's into u's. U equals 1 squared plus 6 times 1 is 7. X equals 3. U is going to be 9 plus 18 is 27. So this becomes the integral from 7 to 27 of 1 over u half of du. And antiderivative for 1 over u with respect to u is going to be the log of the absolute value of u. As u runs from 7 to 27. Okay, so this is half of the difference between the log of 27 and the log of 7. And you could apply log properties if you didn't feel like it, that would be just as good. Turn this one upside down. Yep. So I'll call this one 4. All right, I'm going to let u equal, this one's a little tricky, right? Because I'm going to have to do my u substitution and then I'm going to still have a little bit of a tricky integral. So I'm going to let u equal x squared. So that du is 2x dx. But all I have is x dx, so that's going to be half of du. I promise it's not always half of du. It looks like it based on this problem set, but it's not always the case. So when x is equal to 0, that means that u is going to be 0 squared. And when x is equal to 1, that means u is going to be 1 squared. Now, I am, what am I thinking? I think I've got everything I need. I'm still integrating from 0 to 1. I've got to have half of du, and that's 1 over e to the u. Now 1 over e to the u, it's like, that doesn't look like something I just immediately know how to anti-differentiate, so I might write that as e to the negative u du. And this is definitely something we can work with. An antiderivative for e to the negative u is going to be e to the negative u multiplied by -1 to prepare for the chain rule. And then I'll have, well, that'll really be -half, because that half there. And I'll let u run from 0 to 1. So this is -1/2 of e to the -1 minus e to the -0. Number 5. Okay, I'm going to let u equal -x to the 3rd, so that du is -3x squared dx. When, wait a second, I don't have -3x squared, so I'm going to need to divide by that -3. I have x squared. Whoa, where's the dx on this? That's crazy. Who knows, maybe this is one I typed myself. I don't know, I don't usually forget to type the dx when I'm typing an integral. That's very sloppy, whoever types up this. But, you know, I was just kind of going on a snipping tool spree yesterday when I was putting this together, so you know, sometimes I guess typos happen. I would really try to avoid having a lack of a dx and a UDU problem myself, but whatever. All better now. So, -1/3 of du is x squared dx, which is what I'm supposed to have. So when x is 0, that becomes -x to the 3rd. Well, that's going to become 0. And as x approaches infinity, that becomes, well, really, u is approaching -infinity. All right, so what is going to happen here is I'm going to say now that this is the integral from 0 to -infinity of e to the u du multiplied by negative 1/3. All right. Antiderivative for e to the u is e to the u. And we're going to let u run from 0 up to, well, we can't say u is equal to infinity, so we'll use a b, and we'll consider the limit as b goes to infinity. And that's going to be, okay, just enough room. Oh, I guess I'm approaching negative infinity, which is going to make a difference in this case, of e to the b minus e to the 0, which is 1. Okay. So what's going to happen is, as b goes to negative infinity, e to the b goes towards 0. I'll have 0 minus 1 multiplied by negative 1/3, so I think that'll be positive 1/3. I think I've got just enough room right here to work this one. I think it'll be all right. So this will be number 6. Let u equal, not sign the inside of the composite function, x to the 3/2. So that du is 3/2 x to the 1/2 dx. But if all I have is just square root x dx, okay, that's just regular x to the 1/2. I need to multiply over here 2/3. All right, this is not a definite integral, so I'm pretty much ready to go. This is going to become the integral 2/3 sine u du, right, which is going to be negative 2/3 of the cosine of u plus c. But again, this is an antiderivative in terms of x, so I should be having an x come back, and that would be what is going to be, what is, u is x to the 3/2. All right. So number 7. So what I'm going to do, I'm going to let u be the bottom, e to the x minus x, because the derivative of e to the x minus x is this e to the x minus 1. Okay, it matches up perfectly, no further work is required. X equals 0 gives me u equals e to the 0 minus 0 is 1. And x equals pi, oh, u equals e to the pi minus pi. I don't like that. It's all right. Doesn't matter what I like. What I'm going to do is I'm going to say that this is now the integral from 1 to e to the pi minus pi of 1 over u du, right? Because du was just this whole thing that I had there, so I guess it wouldn't be so bad. So it'll be the log of the absolute value of e to the pi minus pi minus the log of the absolute value of 1, which is going to be 0. Okay, so it's going to be that number. Oh, actually, I think I remember this was a multiple choice question that I gave y'all not even that long ago. All right, for number 8, I'm going to let u be x squared plus 9. So that du is 2x dx. All I have is x dx, so that's going to be half of du. Okay, change the bounds. When x equals 0, that goes to u equaling 9. And when x is 4, u will be 16 and 9 is 25. U is equal to, that'll be 25. Okay, I think I was thinking it was going to be the square root of x squared plus 9. That would be a common error, right? To let u be the square root of x, but it's like, it's not. You need more square roots. That ain't gonna work. So you always want u to be the interior of your composite function. So u is 25. so that I now have an integral from 9 to 25 of 1 over u square rooted, so u to the half, times half of du. So I bump up the power by 1, divide by the new power, that'll be 2 square root of u, as u runs from 9 to 25. I might just do that. So this is going to be square root of 25 is 5, minus the square root of 9 is 3, and that's going to be 2. Let's see, fold this down a little. Oh, 7 and 8. Here's the ones I want to be working on. Hold on a second. Much better there. So for number 9, I'm going to let u equal 4 minus x squared, so that du is negative 2x dx. All I have is x dx. It'll be negative half of du. Then I'll be integrating negative 1/2 square root of u du. And so that'll be 2/3 u to the 3/2 multiplied by a half is going to be, or negative half is negative 1/3 u to the 3/2 plus c. U is 4 minus x squared. Okay. 10. All right, don't need to copy the problem, you can see it. So I'm going to let u be x squared plus 2x because the derivative of this is proportional to that. So if all I have is x plus 1, I'm dividing by 2. Okay. And I will, what am I going to do? Oh, I'm going to actually compute the bounds also. X equals 0 gives u equals 0, and x equals 1 gives u equals 3. So now I'm integrating 0 to 3, half of du. What did I actually do with u? I took e to the u and multiplied by du. Okay, so that's half of e to the u as u runs from 0 to 3. And so that's half of e to the 3 minus e to the 0. All right, there's even more. All right. This one is going to be very similar to one I did before. I'm going to let u be 2x squared plus 2x. Wait, did I already? Oh no, it's just going to work out exactly this. Oh, that's interesting. So what I'm going to do, I don't think it's all going to be exactly the same. And x plus 1, this is going to be half du is x plus 1 dx. So that when I change from 1 to 2, 1 is going to go to 3, 2 goes to 4, plus 4 is 8. So I have the integral from 3 to 8 of 1 over u. Dx is du divided, or x plus 1 dx is du divided by 2. Okay, so this is 1/2 of the log of 8 minus the log of 3. Okay, because the antiderivative of 1 over u with respect to u is natural log of absolute value of u. U is running from 3 to 8, makes us that. All right. Alright, where did the one, oh, I just skipped that one. I'll do that one at the end, I think. So, number 12, I think I'm going to do this two ways. I'm going to do this both ways. So I'm going to let u equal x squared plus 2. So that du is 2x dx. All I have is x dx. So that's half of du. And I need to go from 0 to 1 to u is x squared plus 2. So now I'm integrating from 2 to 3. Half of du, what am I doing with u? I'm taking u squared. Okay, so I'm going to have 27 minus 8 is 19 divided by 6. Right. Now I'm going to bring in a scrap of paper and I'm going to work that one a different way. Right, where was it? Yeah, right here. So what I can also do is I can say x plus 2 squared, or x squared plus 2 squared is this. And that's going to be x to the 4 plus 4x squared plus 4. And I'm still multiplying by an x, and that's x, I don't know, why would I copy like that? Doesn't make sense. It's going to be x to the 5 plus 4x to the 3 plus 4x. And I can integrate that from 0 to 1. So that'll be 1/6 x to the 6th plus 4/4 x to the 4th plus 4 divided by 2, x to the 2 is x runs from 0 to 1. All right, so that's going to give me 1 plus 2 is 3 plus a 6th minus 0. 3 and a 6th is 19 over 6. So that's just another way you could have done that and gotten the same thing. All right, so there's one more UDU. And I guess I'll just turn this upside down and work that way. All right, I'm going to let u, for number 13, I'm going to let u equal 1 plus x squared, so that du is 2x dx. All I have is 1x dx. That's going to be half of du. Okay, so when x equals 1, that corresponds to u equaling 2. And as x approaches infinity, that corresponds to u approaching what? 1 plus x squared? That means u is going to positive infinity as well. So now this is equal to the integral from 1 to infinity of, well, half of d into u. I was taking 1 over u squared. I call that u to the negative 2 du. Okay. So that will be negative 1/2 u to the negative 1. As u runs from 1 up to b, and we'll take the limit as b goes to infinity. Okay. So it's going to be u to the negative 1 is 1 over u, so okay, so negative 1/2 times 0 minus 1 is going to be positive 1/2. That's all the UDU wants. So I'm going to need to get myself a fresh sheet of paper and prepare for doing some integration by parts, some UDV. I'm going to need to pause and reorient this stuff. All right, I think maybe I'll start over my numbering, or maybe I'll just start with A and I'll just call it A. So for A, I've got, okay, I know this is integration by parts because I had separated them all out. Nothing is a derivative of something else, but I do have a product in the integrand. And you're thinking, I late algebra before trigonometry, which means you want to choose the algebraic thing to be u. So I'm going to let u equal x and dv equaling cosine 2x dx, meaning that du is dx, and v is half of the sine of 2x. I started off with a little bit of a tricky one. That's all right, though. Meaning, and now, I know that the integral of u dv is equal to u times v minus the integral of v du. So that's going to be equal to uv x over 2 sine of 2x minus the integral of v du, half sine 2x dx. So moving that down here, that's going to be x over 2 sine of 2x minus, but wait a second, antiderivative for sine is going to be negative cosine, so I think it's going to be plus 1/4 of the cosine of 2x plus c. Let me just double check that. So when I take the derivative, I'll have negative 1/4 sine of 2x multiplied by 2 for the chain. Yeah, okay, cool. So for b, I'll try to write it a little smaller this time. I'll have ilate algebra before exponential, so algebra wants to be u. Let u equal x and let dv equal e to the x dx. Okay, I'll be honest, what I'm seeing on this, I'm not seeing a huge diversity of integration by parts examples. I'm seeing a lot of x multiplied by something and x squared multiplied by something. So I'm pretty much, I don't know if on this one where I'm not going to take u equals x, but actually no, there is, I think there's an x with a log of x. I'm just going to hope. Yeah, no, that's going to be the next one. Okay, and that one will not, and I don't want to just like keep saying ilate algebra before whatever, I never have algebra be after something else. So, but that'll happen in a second. But for the vast majority of, AP calculus questions that require integration by parts, it's going to be x times something. I kind of lost myself there, but all right, du is dx, v is e to the x. So, integral of u dv is equal to u times v, so x e to the x, minus the integral of v du. Okay, so x e to the x minus e to the x plus c. Right, call that one C. It's starting to bleed through, but I'll avoid that area. Algebra before trig. Oh, this is going to be very similar to A, but that'll be all right. U equals x, dv equals sine 2x dx. So meaning that du is dx and v is negative half of cosine of 2x. All right, so this integral of u dv equals u times v minus the integral of v du. Okay, so this is minus the integral of v, so it'll be plus 1/2 the antiderivative of cosine 2x. Okay, so this will be, so I'm not writing, other writing is, I'll have negative x divided by 2 multiplied by cosine of 2x plus 1/4 of the sine of 2x plus c. Anybody's still looking at that? All right, D. Yeah, this one will be a little different. So what I'm going to do, first I'm going to scoot it up. I'm going to use log for u and x squared for dv. So u equals log x, so du is 1 over x dx. making dv the rest of it the x squared and the dx, meaning that v is 1/3 x to the third. Okay, we know that the integral of u dv is equal to u times v minus the integral of v du, which is going to be u times v, so 1/3 of x squared minus the antiderivative, wait, no, u times v. No, I was like, that didn't look right. I was trying to think in my head, how am I going to take the derivative of this and actually have it work out? Which sometimes is like a good thing to think of. If you can't see how you're going to take the derivative and it will work out, then you might need to, like, actually work it out. So it's u times v. Yes, u times v is 1/3 x to the third log of x. So I'm going to write that as x to the third divided by 3 times the log of x minus the antiderivative of v du. That's where I'm going to reduce the power by 1, minus 1/3 of the integral of x squared dx. So I had 1/3 x to the third, I divided it by x, I had 1/3 x squared. So this is going to be equal to x to the 3 divided by 3 multiplied by log of x minus, I think, 1/9 of x to the 3 and plus c. Yep. This one I will call E. So this one is going to be an integration by parts, but it's a definite integral, so I just need to be a little more careful. I just need to remember that I'm going to actually have to evaluate this thing between 0 and pi over 4. So I late u equals x, algebra before trigonometry, dv, and also just on an integration by parts, dv wants to be, it has to be something you can take the antiderivative of easily. Secant squared x is the type of thing that when you see it, you should be thinking, oh wait, that's the derivative of tangent. And so du is dx, v is tangent x. Okay, I know that this integral, yeah, so it's going to be equal to, this is not a situation where we like change the balance or anything. It's going to be uv from 0 to pi over 4. So x, tangent of x, as x runs from 0 to pi over 4, minus the integral from 0 to pi over 4, what? Of v du, which is tangent. Okay, this one might have slipped past me. I might have grabbed this from the wrong textbook, because that's not an antiderivative you're required to know. I think I'm just going to leave that there. And actually, no, this video is already really long, so what I'm going to do, I'm just going to deal with this right now. I'm going to show you how a person would do it, and if you're not interested, then you can just skip forward in the video, you know what I mean? Like, no loss. So I am going to switch up the color maybe to black. So if I wanted to anti-differentiate tangent of x, that is sine of x over cosine x. All right, and so what's going to happen here is, this is going to be a UDU integral. I'm going to let u be cosine x. So I think it's just going to be negative log of the absolute value of cosine x. Let's look and see here. All right, so negative 1 over cosine x. Yeah, this is going to be it. Negative 1 over cosine x multiplied by the derivative of cosine, which is negative sine. That gives you sine over cosine. Okay, this is that. You might in a textbook also, or on the internet, if you just Googled antiderivative of tangent, you might see that this was log of the absolute value of secant x, because of that power property where I can say that's cosine x to the negative 1, which is not inverse cosine, it's secant. Right? So that's just something I'm going to throw out there. The negative log of cosine of, hold on. When x is 0, this thing's going to be 0. So I'm going to have pi over 4 times the tangent of pi over 4 is 1. Okay, so I'll just have pi over 4. Minus, and then, all right, when I plug in pi over 4 for cosine, I'm going to have negative log of root 2 over 2 minus the negative log of when I plug in cosine of 0, that's 1, I'm happy, right? Or log 1, that's 0. But, you know, that's far enough for this one. That one snuck past me. That one probably was not appropriate for y'all's level. But this, you know, I don't know, maybe you were curious about what the antiderivative of tangent was. And now you know. Okay, part F. I'm just trusting at this point in the year you know how to do that one. Okay, I late. Algebra before trig. U equals x squared. dv equals sine x dx. This one, because of the x squared, I know that this is going to require a second iteration of integration by parts. That's okay, though. I'm a very patient person. I can just go ahead and do that. And I'm going to do du 2x dx. V is cosine x. Okay, so this integral is going to be uv minus the integral of v du. Okay, now I'm going to have to do integration by parts on this thing. So I'm going to let u equal 2x, du is 2 dx. Wait a second. That's wrong. Okay. So I did have sine. V is negative cosine x, so this will become positive. Okay, that was a good catch. Really glad I didn't miss that. All right. So if dv is cosine x, that means that v is regular sine of x. It's like positive, and it was positive up there. That didn't make any sense. So this is equal to. And now I guess it's really nice that this is plus uv minus the integral of v du. Okay, so x squared, still visible, 2x times the sine of x plus 2 times the cosine of x plus c. All right. That one required 2 iterations. Let me see, it wasn't that bad. Written on one more, xe to the 2x. All right, maybe I'll go above this one. Call that one g, and so I'm going to let u be x and dv equal e to the 2x. uv minus the integral of v du. Okay, I anti-differentiate that. I'm going to have a fourth to prepare for the chain rule. Got to have my plus c. And that's going to be all. I think since this video went pretty long and the period is about to end, I'm going to just restrict the discussion in this video to the front side of this worksheet. I will record a separate video for the problems on the back of this set of practice problems.